Hi guys, today let's talk about protocols. First, what is Internet Protocol? It is a protocol or set of rules for routing and addressing packets of data so that they can travel across networks and arrive at the correct destination. Data traversing the Internet is divided into smaller pieces, called packets. Data from the server flows downwards through the switch and then to the connected devices. For example, a device requests data from the server. The server sends it to the appropriate switch, then forward to the requesting device. Next is HTTP. The Hypertext Transfer Protocol is the foundation of the World Wide Web and is used to load web pages using hypertext links. It is an application layer protocol designed to transfer information between network devices and runs on top of other layers of the network protocol stack. Now, let's watch a video about HTTP.
All the information is sent in clear text. So all the information that is exchanged between your computer and that web server, which includes any text that you type on that website, that information is transferred over the public internet. And because it's transferred in clear text, it's vulnerable to anybody who wants it, such as hackers. Now, normally this would not be a big deal if you were just browsing regular websites and no sensitive data such as passwords or credit card information are being used. But if you were to type in personal sensitive data like your name, address, phone number, passwords, or credit card information, that sensitive data goes from your computer and then it has to travel across the public internet to get to that web server. And this makes your data vulnerable, because a hacker that's somewhere on the internet can listen in as that data is being transferred and steal your information. So as you can see, this hacker is stealing personal information as it's traveling over the internet. So he has a name, phone number, address, credit card numbers, and so on. So this is a problem as far as security.
The next one is TCP. Transmission Control Protocol is a communication standard that enables devices and programs to exchange messages over a network. It's a core technology that ensures data is delivered accurately, in the correct order, and reliably across networks. What does TCP do? First, it establishes a connection to the source and destination. Second is breaks data into packet. Third, transmit corrupted packets, and last is it protects data delivery using advanced protocol to maintain its safety. In the picture below is the three-way handshake of TCP. And now, what is DNS? Domain Name System is the phone book of the Internet. Humans access information online through domain names, like YouTube.com or Google.com. Web browsers interact through Internet Protocol IP addresses. DNS translates domain names to IP addresses so browsers can load Internet resources. It has unique IP address, IPv4, which is the short term of IPv6, which is more complex IP address. Let's go on to the breakdown of protocols and watch this video.
Here is the TCP IP model. 4 simple layers: application, transport, internet, and link. And just like the OSI model, it's numbered from the bottom up, but the direction depends on if you're sending or receiving traffic. So this is the original model, but it has been updated. Here is the brand new, freshly designed model. 1 extra layer and 1 renamed layer. That's it. The link layer has been split into data link and physical, and the internet layer has been renamed the network layer. Simple, right? It gets even better when we compare the TCP/IP model to the OSI model. Now, if you remember, the OSI model has 7 layers compared to our 5 here. But when you look at it, you'll notice the application, presentation, and session layers are just shown as application layer in the TCP/IP model. All the other layers line up nicely, which is great because we should already know the concept of how this works. So let's remind ourselves about the protocols and devices at each layer. At the application layer, we have application protocols such as HTTP, FTP, and SMTP. The 2 most common transport protocols are TCP and UDP. Port numbers are also added here. At the network layer, we have the Internet Protocol, or IP. Routers also operate at this layer. The data link layer contains Ethernet. Switches typically operate at this layer, although you can get layer 3 switches that have some routing capabilities. Finally, we have the physical layer. Think of everything we can touch and feel here, things like cables and network interface cards. Okay, so as we send data, each layer will add its own bit of information. This process is called encapsulation. When we hit the physical layer, the data is transmitted over to the receiving device. The receiving device then starts to decapsulate the data. We saw this in the OSI model, but in this video we're going to take a closer look. We start with our application data at layer 5. This is then passed down to the next layer where the transport information is added. Let's say it's a TCP header. Each time a header is added, this will contain specific information. For example, a TCP header will contain things like the source and destination port number, sequence numbers, and a few more bits of information. We'll go over this in more detail in a separate video. We then move to the network layer, where we add the IP header. This will contain the source and destination IP address, as well as some other bits of information. Lastly, we have the data link layer. Here we add not only a header, but a trailer as well. The header contains mainly the destination and source MAC address, and the trailer contains some error checking information that the receiving side can check and make sure the data has been received correctly. Once the data hits the physical layer, it is physically transmitted. So, we've gone through the encapsulation process. It's important to note that at each stage, the data has a specific name. At layer 5, the data is called, well, it's just called data at this stage. Once the transport information has been added, it's now called a segment. Adding the network layer information makes our segment a packet. And finally, once we add our data link information, the packet becomes a frame. Now, once data has been transmitted, the receiving computer decapsulates the information. It will check the destination MAC address for that frame, and if the frame is destined for our computer, it's processed further. The computer then checks the IP information off the packet. Again, if the packet is destined for our computer, it's processed further. The transport information is read and the application data is sent to the receiving application. So that's it for
Overall, the internet relies on IP, TCP, DNS, and HTTP to function smoothly. IP provides unique addresses and routes data between devices. TCP ensures reliable data transmission by confirming packet delivery and order. DNS translates domain names to IP addresses, making it easy to navigate the web without memorizing numbers. HTTP enables data exchange on websites through a request-response model. Together, these protocols provide reliable, accessible, and user-friendly internet connectivity. It is essential to the internet's functionality, reliability, and accessibility. These protocols work together to manage data routing, ensure connection integrity, simplify navigation, and facilitate web interactions, forming the backbone of modern digital communication and enabling seamless global connectivity for billions of users. Their importance in supporting everything from casual browsing to critical online services cannot be overstated. That's all for today. See ya.